Hi guys, today I'm going to teach you how to multiply and divide rational numbers. So by the end of this lesson, you'll be able to follow the process for multiplying and dividing decimals and fractions, both positive and negative. So these are types of rational numbers along with integers that we'll now be able to multiply and divide. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. Let's go ahead and get started with some review. So we're just going to start by reviewing the process for multiplying and dividing positive decimals in the table. So we'll start with just multiplying decimals. We'll start here. In the first blank, it says multiply the digits as usual, ignoring the what? Ignoring the decimal point. We're going to go ahead and just ignore the decimal point. Let's go ahead and look at that. Just starting out with this example, 12.8 times 6.3. So before we go to the next step, let's just review this sixth grade math. So we'll start by multiplying these out. And the first step it says is to ignore the decimal and multiply like normal. So I'm just going to erase it. We're going to just ignore it and then multiply like normal. So pay attention to this part. This is a review of sixth grade math. So we're going to go ahead and just multiply this 4-digit number by a 2-digit number. We'll start with the 3. So we always start with this number. We're going to multiply it to each one of the top. So we're going to go ahead and do 3 times 0 is 0. Anything times 0 is 0. 3 times 8 is 24. The 2 gets carried. 3 times 2. So remember, I'm just going down the line. 3 times 2 is 6, plus the 2 that's on top is 8, and then 3 times 1 is 3. Anything times 1 is itself. So now we do the next section. And for this next step, which I'm going to do in orange, I just want to go ahead and just erase this little 2 at the top here. Anything I did in green, I'm just going to ignore and erase. I'm going to start by putting a placeholder 0. I always put a placeholder 0. This is how I do multiplication. You might learn it different. Do whatever method works for you to multiply. But I always put a placeholder 0 and then multiply the 6 to each one of these numbers. So that's what you're going to do. You're going to take 6 times 0, which is 0. 6 times 8 is 48. Carry the 4. 6 times 2 is 12. Plus the 4 is 16. So carry that 1. 6 times 1 is 6. Plus 1 is 7. It's important as you do multiplication like this to follow the place value for these. So they always want to line up, because what you're going to do next is add. So now you add the products of 3 times each of those and then 6 times each of those numbers, and you just add straight down the line. So 0 plus 0 is 0. 4 plus 0 is 4. 8 plus 8 is 16. You carry the 1 just like normal. 6 plus 3 is 9. Plus 1 is 10. So you are left with 80, 64, 0. But we don't know where the decimal goes right now. Remember, when we started out, we had a decimal point in the 12.8 and the 6.3. We ignored it for the first step. So now we have these numbers and we don't know how to read this yet. So we're going to go back to our instructions and finish this out. So the first step was to multiply the digits as usual, ignoring the decimal point. The product will have the same number of places behind the decimal as the multiplicand and the multiplier combined. I hope I said that word right. Multiplicand? I don't know. Multiplicand and multiplier are these two numbers. The two numbers that you're going to multiply to get your product. So the numbers that you're multiplying. So the decimal point is after 2 places here and after 1 place here. So combined, that's after 3 places. When I look back at my answer, I would go ahead and count 1, 2, 3. So 3 from the left. So my final answer is 80.64, or 80 and 64 hundredths. And I can ignore that 0 because anything after a 4 is just going to be 0. So anything after that decimal, if it doesn't say a number, it's just going to be 0. Invisible zeros. So that's my final answer. So for multiplying, you just multiply like normal. Follow your rules for multiplication, which we can review those as we go. You don't have to be perfect at those yet. I know it's been a minute since you've done those. And then we follow the amount of places behind the decimal as the two numbers combined. To be really honest with you, this is something I'm not super comfortable with. I find these kind of confusing, and it's kind of a long process, and I would probably just type this in on the calculator at this point, but I do want you to know the process in case there are no calculator questions where you need to use this for. So let's go ahead and switch gears a little bit and look at division. So we're going to look at dividing decimals. So read these instructions along with me and just pause if you have a question and make sure you ask me. It says, in order to make the divisor a whole number, multiply it by a power of 10. And then when you've done that, multiply the dividend by the same power of 10. So divisor and dividend are the two words that mean, in this example, the thing you're dividing out of, and then the other number. So the two numbers you're dividing, those are the divisor and dividend. We are going to multiply by a power of 10. That means we're just going to move the decimal over. So ignore that stuff about moving the power of 10. It just means move the decimal over one time. If you move it over one time to get it to be a whole number, 437, do it here. So on the 19, the whole number is 19, so there's invisible 0.0 at the end of it. Move the decimal over 1, add a 0. So you have divided by 190. This is the same type of problem. So 43.7 divided by 19 is basically the same thing as 437 divided by 190. So now the next thing we're going to do is just divide. So let's go ahead and pull this out. You might want to pull your whiteboard out or a piece of paper and do this problem longhand out on the whiteboard. So if I'm looking at this, I have too big of numbers and I don't know what 190 goes into 437 to. So I'm just going to go ahead and off to the side, start multiplying. I want to start with, I know 190 times 1 is itself. So I'm going to start with 2. I'm just going to multiply by each multiple, starting with 2, then multiply by 3, and then 4 to see if I can get a number that is close to, but not over 437. So 2 times 0 is not 2, excuse me, that is 0. 2 times 9 is 18. 2 times 1 is 2, plus 1 is 3. So we got to 380. So I'm just going to double check here. 190 times 3. So I'm just going down the line because I remember I don't know if it goes in 1 time, 2 times, 3 times. So it goes in at least 2 because 437 is the number I'm trying to get to. 380 is what I got when I multiplied by 2. 190 times 3 is 0 here, and then 3 times 9 is 27. So I got 570. So it can't be 3 because then it would be too big. So it's going to have to be 2. So I'm going to write 2 here on the far end of this problem. So 190 goes into 437 2 times evenly. So then I carry it down. But I got a 390 when I multiplied that. And then I subtract. So I'm just following my division rules. So 7 minus 0 is 7. Can't take away, so I borrow. 13 minus 8 is 5. So I've got 57 left. So what I do next is write my remainder as a fraction, 57 over 190. And this can be simplified. I'm going to tell you right now, this is again a moment where I would pull out the calculator. So I would pull out the calculator and do 57 divided by 190. That line means divide. So that's going to give you a decimal point of 0.3. But you could also think 57 goes into 190 3 times. So you're going to have a 3 here. Let's look back at our instructions. It says to divide like normal and then bring the decimal directly above into the quotient, which means the answer to a division problem. So looking back at this, what I want to do is I know that 2 went in there evenly, and then I'm looking at a 57 remainder. Once I get a remainder, I'm going to put a decimal. So decimal point right there. And that is it. That is how you divide with decimals. Again, this is another example of a time where I might just pull out my calculator. But because this is 7th grade math, and this is supposed to be the no calculator section, you're really supposed to not do it. You're not supposed to use a calculator at first. You're supposed to be able to just do it by hand and then check with the calculator. But I find these to be really time consuming and not really relevant to real life math. So we're going to kind of skim past these and then move to fractions. So before we do that though, the one thing that is really important about these is that the rules for integers are the same for rational numbers. So multiplying and dividing integer rules. Let's go ahead and just check these out real quick. If the signs are the same, the product or quotient is positive. All that means is if a positive times a positive equals a positive, so does a negative times a negative. That also equals a positive. So all 4 of these multiplication and division problems will all have positive products or quotients because they are a positive times a positive or a negative divided by a negative and so on. So always remember this, like misery loves company. If you're in a bad mood and I'm in a bad mood, we're going to be miserable together and we're going to be happy about that. We love company when we're miserable. The other side of that is if the signs are different, the product or quotient is negative. So in other words, this means that a positive times a negative is going to be negative 100% of the time. Listen closely. A negative divided by a positive is going to be negative 100% of the time. So if you have different signs being multiplied or divided, the answer will be negative always. So a negative is times a positive here, the answer will be negative. The positive divided by the negative here means the answer will be negative. In every one of these problems, you'll have a negative answer. I would like you to try these on your own without a calculator. Remember, the first thing you should do is try to figure out what is the sign going to be. So for this one, I know it's going to be positive, so I would do that and then multiply it out using your multiplication rules for decimals. Same for one like this. You would divide. You know that the answer is going to be negative, and then you divide like normal. I'm not going to go through these with you because, like I said, I don't want to waste anybody's time on these. If you want to practice these by yourself and then check and get feedback, we can do that. But I'm just going to go ahead and move on to fractions. So I see multiplying and dividing fractions way more in 7th grade math. And then this is what I see way more up to the high school level. And you sometimes don't need a calculator for these. Sometimes the calculator can be more confusing because there's only a few simple rules for multiplying and dividing fractions. So let's go ahead and get started. It says for multiplying fractions in this box, our first step is to change each mixed number to an improper fraction. We should already be in the habit of doing that. When we were adding and subtracting these numbers, we weren't using them as mixed numbers. We were rewriting them as improper fractions. Remember, we multiply and then we add what's on top. Keeping the denominator, we have an improper fraction. So we'll review that again today. But we've already done that so far. So this is review. Let's look at the next one. It just says multiply the numerators. That means only multiply the top part of the fraction. So the first step is to change each mixed number to an improper fraction and then only multiply the numerators. So let's go ahead and look at this with an example below. So it says 7/8 times 1 1/2. So let's start with the first step, and you could probably do the first step by yourself. We already have a regular 7/8, so we'll keep that, but we want to convert 1 1/2 into a improper fraction. So you multiply 2 times 1, which is 2, plus the 1 on top. So you multiply down and then add what's on top. So 2 times 1 is 2, plus 1 is 3, and then you keep the denominator, which was 2. So that's how you get a mixed number to an improper fraction. The next rule said to multiply the numerators. Go ahead and by yourself just multiply the numerators. Okay, so you should have multiplied 7 times 3 and got 21. Let's look at the next step. Multiply the denominators. So when we were looking at adding and subtracting, we don't touch the denominator. The denominator gets left alone. But for multiplying, you're allowed to multiply the numerators and multiply the denominators. You're actually supposed to. You just multiply straight across for both of them. So 8 times 2 is 16. And then that's it, folks. That is all you do for multiplying. You just make sure that you multiply the top and the bottom. You have an improper fraction, so the last step was going to be to simplify, but you know to do that for an adding, subtracting, multiplying problem already. You know to simplify this. So you think, how many times does 16 go into 21 evenly? It goes in one whole time with 5/16 as my remainder. So we'll get some more practice with that, but let's go ahead and look at division. So let's look at the rules for division. So we'll change each mixed number to an improper fraction the same way with multiplications. We'll start the steps the same way. And then we'll rewrite the first fraction. So this 2 3/4, we'll go ahead and change multiplying 4 times 2 and then adding what's on top. So 4 times 2 is 8 plus 1, 2, 3 on the top gives you 11. So you have 11/4. And then here's the kicker. This is the biggest secret about dividing fractions. So pay attention to this. We never ever divide fractions. You never ever ever divide a fraction. Instead, we want to do something called keep, change, flip. We want to multiply by their reciprocal. So we're going to learn what that word means in just a second. So instead of doing division, we will multiply. We're going to multiply instead of divide. But because I can't change just any problem to multiplication, I have to do something to the second fraction. So I keep the first fraction, I've changed division to multiplication, and now I'm going to flip the second fraction. That's called the reciprocal. Whenever I flip the fraction upside down, that's called the reciprocal. So 3/2 is the reciprocal of 2/3. I just flipped it upside down. Then once we have it like that, we can multiply like normal. So the key to division, one more time, is to keep the first number, change the division to multiplication, and then flip the second fraction. So we keep, change, flip, and then multiply it out. So we multiply like normal, 33 on top, because 3 times 11 is 33, and 4 times 2 is 8. So then we can simplify if we can. We don't want to leave our answers improper. We want to make them a final answer as a mixed number. So we have 8 goes into 33 4 whole times, with 1 left over out of 8. So now let's think back to our rules about integer operations when we were multiplying integer values and dividing integer values. And I just want to start by reminding us of that rule. If the signs are the same, the product or quotient is positive. This is just the rule you have to remember about multiplying and dividing with positive and negative numbers. A positive times a positive is always positive, but a negative times a negative is also positive. So we're going to remember that rule for multiplying and dividing only. So now let's go ahead and get started with our fractions. So let's look at the first example. 3/5 times 2/3. When we multiply fractions, you just multiply straight across. So 3 times 2 is 6, and 5 times 3 is 15. So go ahead and look at the next one, and I want you to try negative 5/6 times negative 3/4 by yourself, and then press play when you're ready to check. So by now, you should have tried this out for yourself. You should look at the signs first. It's a negative times a negative, so your answer will be positive. When you multiply two numbers that are the same sign, the quotient or the product is positive. So 5 times 3 we can just go ahead and do, which is 15, and 6 times 4 is 24. So your answer for this problem would be 15/24. I also just wanted to let you know that I've not simplified either one of these. Both these fractions can be simplified. When you simplify a fraction, you think, is there a number that goes into both of those fractions? And this will also happen on your calculator if you wanted to check this on that Desmos calculator. If you type in 6/15, it'll simplify to 2/5 because 3 goes into 6 and 15. So if it asks you to simplify your answer, 2/5 would be the most correct because it's the most simplified, but 6/15 is an equivalent fraction for 2/5. Those are the same fraction, just written in different terms. Same for 15/24. You can rewrite this as 5/8 because 3 goes into both those numbers. So now let's look at our division example. So this is the thing you have to remember. So multiplying, I think, is pretty easy because you're just multiplying straight across. But with division, we have a process. You should always see this little division sign between fractions, and you should think, I don't divide. I multiply by the flip. I multiply by the reciprocal. So as we go through this problem, we're going to keep, change, flip. What I mean by that is we're going to keep the first number. So you have -3/10. We're going to keep -3/10. Change the divide to a times, and I'm going to write it like an X, or I could write it with a little dot like they are doing in the other problems. And then I'm going to flip this other fraction. So I'm going to flip the last one. So instead of 4/5, I'm going to multiply by 5/4. And remember, it is negative. So your negative can just go on top. Remember, we're just following the steps that we wrote up here. We saw that they were both regular fractions, so we didn't need to change mixed numbers. We changed division to multiplication. We found the reciprocal. Then we multiply like normal as the last step. So we're just following instructions right now. You're just following step by step what to do here. So you can look at 5 times 3 and get 15. It's a negative times a negative, so your answer will be positive. And then 4 times 10 is 40. You look at 15 and 40, and you should be able to see that you can simplify that because they're both divisible by 5. So 5 goes into 15 3 times, and 5 goes into 40 8 times. So the final answer would be 3/8, but 15/40 is also correct. So I'm going to clear this out in just a second. So take a second to copy that down. Okay, so I just cleared that out so that way I could write for the next one. I want you to try the next one by yourself. This is the same process with the added step of having a mixed fraction. So change that mixed fraction to an improper fraction and then multiply it out by keep, change, flip. So go ahead and try that by yourself and then press play and you're ready to check. Okay, so by now you should have started out at least by multiplying and then adding to get this mixed number to an improper fraction. So 8 times 1 is 8, plus 3 is 9, 10, 11, and then keep what's on the bottom. So 11/8 is the equivalent fraction for 1 3/8. We want to change the division to a times. We never divide fractions. We always multiply by their reciprocal. So reciprocal just means flipped fraction. So we multiply by 8/1. 1/8 is the reciprocal of 8/1. So once you have them written as a multiplication problem, you just multiply like normal. So 11 times 8 is 88. And then 8 times 1 is 8. So you have 88/8, which is the same thing as 88 divided by 8. 8 goes into both of them. So your correct answer, final answer, my simplified answer is 11 or 11/1. Those are the same number. 11 and 11/1 are the same thing. So before I go any further, and I realize this video is getting a little bit long, I just want to explain real quick why multiplying by the reciprocal is the same thing as dividing. So let me just show you this with a pizza. I love food, I love pizza, and it's the best way to explain problems to me. So let's say I want to divide this pizza in half, or divide it by 2. So I want to have 2 even slices. So I just cut it down the middle. That's divide by 2. Divide by 2 is the same thing as take half of the pizza, okay? So that's, if I told you to divide by 2, divide this pizza into 2 slices, you would cut it in half. And cut it in half is the same thing as taking half of the pizza. If I said take half of the pizza, you would do the same thing, right? You would cut it in half. You would divide it into 2. But remember, in multiplication vocabulary, of means times. So 1/2 times the pizza is the same thing as divide by 2. 1/2 and 2 are reciprocals. 2/1 is the same thing as the flipped fraction of 1/2. So take a second to think about that. I just want you to realize we can multiply by the reciprocal because it's the same thing as dividing. I'll go ahead and skip to this next section. If the signs are different, the product or quotient is negative, and negative times a positive is always going to give you a negative answer. So when we multiply or divide only, a negative times a positive or a positive times a negative will give you a negative answer. The same thing works with division. So I just want you to remember that and go through these by yourself. We'll check these together. If you need help with these, let me know. And then if you want to, you can look at this section down here for the rules of positive and negatives. But there's a pattern that you'll be able to figure out, but you don't have to do that if you don't want to. All right, guys, that's it. If you made it to the end of this video, please put your favorite holiday in the comments. Today we went over multiplying and dividing rational numbers. So now you should be able to follow the process for multiplying and dividing decimals and fractions. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.